Hello, everyone. My name is Ross Signal, the Director of Product Management and Marketing with Dranetz. I'm joined in the room here, two gentlemen you probably know by now, Ken DeMario and Thurman Bridgers. I'm Ross over here. We're trying a little different format today. As you can see, we have a webcam on the room itself. We'll do a little bit of hands-on demonstrations as well. So please be patient as we experiment with these new methods. And also, I want to share that our webcam's a little blurry on the right-hand side, so we have a replacement on order, so we apologize for that. So anyway, let's get started here. Again, we have our technical support staff, Thurman and Ken. They and all of us will be available during the meeting for chats and questions and answers. So we will be monitoring the chat during our presentation today. However, just please be patient. We'll try to stop at the appropriate times to answer questions, but if we don't get to your question, we will definitely attack all the questions at the end and review them. So just please be patient with that. Our next training session will be on December 2nd. We're going to take a week off for our Thanksgiving here in the United States. And that session will be our second module of our portable applications training. Last week, we focused on generator testing and our Dran expert. In 2 weeks from today, on December 2nd, we're going to focus on the HDPQ family. It's IEEE 519 2014 compliance testing, VFD monitoring, and DC circuit monitoring. So similar to last week, we're going to go through and show how to configure, set up, monitor, and review data for these particular types of applications. So if you have not registered, please just go back to the same web page that you registered before to register for those web meetings. Okay, the focus of today, we are back doing our operational training of our HDPQ family, which includes the Plus and the SP. We have a more detailed list in a couple slides of what we're going to cover. But in general, we're going to speak about how to set up the instrument. We're going to demonstrate the automatic and the manual wizards, review basically how to do basic analysis on the instrument, and how to do analysis using our DranView software. Excuse me, we're not going to get extremely detailed in any of these parts. What we recommend for detailed setup information, attend our application training, and we'll focus on specific setups and how to use those. We're happy to answer your questions today, but the thing with the setups, it's really application dependent. You can have sort of a generic setup or for very specific applications like we're covering in other webinars. So you know, if you have specific questions, we're happy to answer them, but we'll go into detail on the specific applications. So again, please chat your questions. We have too many folks here to have a voice dialogue. So we are monitoring the chats right now. My suggestion is to please chat to everyone, and Ken, Thurman, and myself will all see this. And again, we'll try to respond today or immediately when we see some chats, but certainly by the end. So please be patient. And today's web meeting, like our others, over the summer and in the fall, is being recorded. So we have our webcast or media page on our website. We'll post it on there with the other chats, with the other presentations, probably by the end of the week. So if you have some colleagues who weren't able to attend this, or maybe you weren't able to attend a prior session, we have a list of recordings there, maybe about 8 or 10, and we'll continue to build them. So just a little bit about Dranetz for those of you who are new to our web training. We are located in Edison, New Jersey, stone's throw from New York City. You can see here's us in Edison, and here's Manhattan right over here in non-COVID times, we'll say. We had a lot of visitors who actually wanted to see New York City, but did it under the guise of visiting Dranetz. So we're in a very convenient location within an hour of New York. Hopefully when COVID calms down, we'll be able to welcome people back here, and you folks will want to travel and come back and visit us. So we're in a very strategic location. Just a review of our product and service portfolio. We're the manufacturer of portable three-phase power quality demand and energy instruments. The examples are our HDPQ family that we're going to talk about today. Another example is our Dranexpert, the new product that we've been talking about. We also make permanently installed power quality demand and energy instruments. So the portable ones are for portability, move around easily. The permanently installed, they're fixed installed in your substations, in your switchgear, or whatever it is. And we also have accompanying analysis software for each product family. So our DranView product line, our DranView software, which we'll be elaborating on today, is more intended for our portable products, and our PQView and PQView DE is more intended for our fixed family of products. And our last web meeting of the fall 2020, we have a tour of PQView and PQView DE, which Thurman will be doing. I believe that's on December 18th. So again, please register for that if you haven't done so already. We also are the U.S. master distributor of our parent company's products. We are owned by a company called Gauss & Metrowatt. They make a full line of products, precision multimeters and testers, electrical safety testers, installation, and other testers, as well as light meters from another sister company called Gauss & Photo. And we are the master distributor of their entire product line as well. Generally, if you see products sold by Dranetz that are green in color, they likely come from Gauss & Metrowatt, or one of our sister companies. We do offer free technical support. This is actually part of that, where we want to make sure you folks have knowledge on the products. We're happy to speak to you, email, call us, attend these web meetings. We want to make sure you're prepared to use the products. We want to help you with that. But there does come a time where there is paid for training as well, where it's beyond the capabilities or the intent of our free technical support. So we certainly do a lot of remote training right now. Certainly in the times of COVID, we do a lot of web meetings under our Zoom or whatever the customer's account, to help our customers, not only help them get the products installed, properly configured for their application, get data out of the products, analyze it in the software, and know how to use that for their particular application. So that is designed around your specific needs, whether it be a portable or a fixed product, or quite candidly, both in a lot of applications. This is on-site training that we hope to resume soon, but we've taken it remote. And that's mostly Ken and Thurman who do a lot of that. Our website, Dranetz.com, it's where you registered for this training. It's not only, of course, an online product catalog for our products, but there are a lot of case studies, tech tips, and everything else related to our products in the industry. So please use that as a resource. That's where we house the library of recordings of these sessions. So you'll see a lot of educational material on there, and a lot of our social media posts and our emails will direct you back to our website for the collateral material there. So if you ever want to know the latest information about Dranetz, just log into our webpage, where our website, our homepage, is constantly being updated in the banners for current information, and follow us on your social media platform of choice. Primarily Facebook or LinkedIn. Just a note about Dranetz, the products that are designed by Dranetz, are designed in this very building in Edison that we're in right now, are also manufactured in our facility here as well. So we're proud to say made in the United States. So things that we design, we build, okay? And we're happy and we're proud to share that. So just some images of the products you can see on the right-hand side here. This is our portable product line, our HDPQ and our HDPQ Plus and our SP products, which we're going to be focusing on operational training today. We have our fairly new Dranexpert product that we started shipping in October. We recently introduced, and here's the accompanying DranView software, which works with this entire product family. We also have our fixed family of instruments, which is a line of full-featured PQ instruments for high demand applications and very unique things that only the Dranetz products can provide, down to just energy meters and panel meters. And they are all pulled together primarily by our PQView or our PQView DE software, which again, we have a training session in December on that. And here you can see an example or some examples of the Gauss & Metrowatt product line: multimeters, safety testers, light meters, and these are machine and other types of testers. So you can see what I was referring to before with the green color. So if you have any more questions about the Dranetz line or the Gauss & Metrowatt line, just please reach out to us or send us a chat. We're happy to answer them. So focusing on today's training, this is just generic and general training, operational training on the HDPQ family, which really encompasses the Plus line, Again, we have our Visa, our Guide, our Explorer 400. That's available on the Plus Portable and the SP packages, where the portable package includes the color touch display that you see there. The SP package does not have that. It's in a remote package, but has the benefit of being able to power from the phase that you're measuring. So these are 1,000-volt instruments. However, the SP has a little power supply input on the left where you can jumper over and power the instrument from anything you're measuring 600 volts and less. So it's a 1,000-volt instrument, but the power supply is only rated at 600 volts AC and 500 volts DC. So that's one of the big differentiating features between the portable package and the SP package. They have the exact same communication. So on a portable, where you may use a touchscreen to set it up and do data analysis and use the communications, meaning Ethernet or Wi-Fi, if it's available in that model, as a secondary form of user interface. Well, that secondary form on the portable becomes the primary user interface on the SP. Okay, but it is the exact same interface, and these are the exact same instruments measurement-wise. So they set up exactly the same. What you see is identical, and what they measure is identical. So when you peel back the cover, they are really the same instruments on the inside. So once you know one, you absolutely know the other, given the differences that we spoke about before. So what we're going to focus on today, and we're going to break this up between myself, Thurman, and Ken, and get a little more visual again. We're going to do a hardware tour of the instrument that Ken's going to do, just showing the various interfaces, the inputs, and we'll go into a full screen view there, so you can see Ken do that. We're going to just do a general overview of the user interface, you know, what the general things are that are displayed on there. We're going to do a brief overview of real-time meters, how to access them, which buttons to push to see a scope mode or a text mode or something like that. And we're going to spend probably the most of our time on the instrument itself on the monitoring setups. We'll go through the automatic setups where the instrument sets itself up with just a little basic information from you as the user, and then the wizard setup, which is that step-by-step process to set it up for a monitoring application. However, we're not going to focus on any particular application, so it's going to be a fairly high-level overview. Again, we're happy to answer any specific questions via the chat, but the details to set the instrument up for a particular application will come when we cover those applications, such as we did last week and we'll do in 2 weeks from now. And we'll also show you how to start and stop monitoring, which is very, very easy to do. We're going to give a little brief overview on how to review data on the instrument, and Thurman will be providing these sections here. Just how to do a timeline, trends, and look at events. Again, we're not going to do that analysis. We'll just point and show you where those capabilities are. Then the next step is how to get data out of the instrument and get it to your computer, and then ultimately in Dranview. And there's two ways to do that. One is through a USB jump drive, which you use a sneaker net to carry to your Dranview computer, or you just download it via Dranview, and it winds up in your Dranview computer, and magically you're just seeing the data right there once it's arrived. And then we're going to continue on. I believe Ken's going to do this section of a Dranview tour, how to open data in Dranview, how to browse data in Dranview, just a high-level tour of Dranview itself. So that's really what we're going to cover. Again, let's focus on the chats for any questions. And without further ado, I think our first section is the hardware tour. So let me just stop sharing, and Ken's is gonna stand up and describe the hardware. So just give it a second. There you go.
Okay. Hello, everyone out there. This is the HDPQ Explorer. It's a 1,000-volt instrument. We got 4 differential inputs on top for your voltages. What this allows you to do is do more than just delta and Y. It also gives you some of the other odd inputs, you know, high leg, open leg, delta. We also have 4 inputs for 4 different CTs. You can pick the different CTs that you want. You know, we have a couple different ones. Talk to us about that later on. The left side of the instrument has Ethernet port. This is hardwire Ethernet, and also has USB import for getting the data out of it. It is not for communications between your instrument and your computer. It's just to retrieve data out of it. The right side has our power switch on it, has also an optional GPS input. If you need some GPS, you need the accuracy. If you need internal NTP is not enough for you, the GPS. Also, the power input, it's 12 volts power input. The back of the instrument has a little built-in easel for it so that you can stand the instrument up. Also, these back here allow you little knobs to dress the wires and take the wires and do everything that you need for it. We also have a little camera on the front. This will copy whatever's on the screen to your database. The center is for a mini report, to do a little mini report on into the instrument while you're recording. And then the question mark right here. People always ask me, where's the manual? I don't have a manual. Well, guess what? You hit the little question mark, the manual will come up on the screen to the screen that you're on. So you always have the manual with you. If you need help and you can't get access to Thurman or myself, just press the little question mark and the manual will come up to you with no problem. It's got a nice little rubber boot on it, the protection, so it will survive a 4-foot drop. We've done that many times. Basically, that's it.
Okay. All right, nice job. Thank you, Ken. Let me start sharing again, and we're going to just talk about a general overview of the user interface. Okay, just give me 1 second here. Okay, just as a brief overview of the user interface, and I'm sharing, this is what I'm doing here just to describe. This is an instrument that we're going to be using for today's session that's mounted at the service entrance of our building. Our utility is Public Service Electric and Gas, PSE&G, and this is a service to our approximately 60,000 square foot building here in Edison. We've got a lot of instrumentation there. We do have an HDPQ, actually several HDPQs on the service entrance. So this is the real-time metering that you see here, and Thurman's going to actually continue when I'm done and describe, based upon this particular instrument. So we have a VNC app that's running on our computers here. You can do this within DranView itself. So we have a direct communication right to the instrument. So if I were in front of that instrument, downstairs on the first floor of our building, this is exactly what would be seen on the front panel, the LCD of the instrument. This happens to be an HDPQ Plus portable. However, we could just as easily have our SP product there, and it would look the same remotely, but there would not be a local LCD interface on the instrument for the SP. And what you're going to see here, and what Thurman's going to describe, is 90% the same for a Visa, a Guide, an Explorer, and Explorer 400. User interface wise, there's very few differences between them. And really the difference lies in the options that are in the features that are available, that, like as an example, high-speed transients on an Explorer, you have configurations for that are not available on the Guide because it does not have that capability. Same thing for Wi-Fi on the Guide is not available on the Visa. So things like that, you'll notice some differences, but they are 90+% the same. So just as a brief overview, and I hope you can see my mouse, and you can. This is the user interface. It's divided into 3 areas. We have mostly a taskbar, what we call interface at the top. And this is basically where you can get your time, you can get a battery status, know if you're connected, and get the information on your Wi-Fi. Maybe you want to get your Wi-Fi, your Ethernet, maybe you want to get your IP address. We also have a status icon here. And you can see that's an icon of the instrument. Oftentimes, if you're working with our tech support and you think you may have an issue, they may ask you for the firmware version of your instrument. So you would simply click there, and then the firmware information, the instrument status would come up, and there'd be some information that they'll ask probably on this line over here. So just to give a brief description. And also, when you have a USB drive installed in the instrument, you plug it in the side. When it's mounted and recognized, you will see an icon of a USB jump drive, flash drive show up in here. So, and Thurman will refer to that before or afterwards. So we have the task area of the instrument, which is just for general instrument information. We have what we call the working area of most screens, which is where the meat and potatoes is for the product and for the interface. And you can see right here, this happens to be the home screen of the instrument, which has the monitoring status, if monitoring's on and off, different facts about the monitoring, as well as real-time meters. And then many screens, such as this one and what we call the working screens, will have information at the bottom of the screen. So as an example, if I go to a scope mode here, which I just clicked right over here, it'll load up a real-time oscilloscope mode, which you can see. And then we have soft keys at the bottom. So these are the same keys that I'm showing you remotely that you'd be touching on the portable device that you'd be touching remotely as like what I'm doing for the SP or remote connection to the portable device. So again, we have the taskbar at the top. We have working area, which is kind of what you're viewing at the time, and then soft keys at the bottom that relate directly to what's being displayed in the working area. So that's just a general overview of the user interface, just what the different components are. And now we'll just pass it over to Thurman, who will talk about the details of the real time, and he'll progress through that.
Thank you, Ross. If you permit me to share, I will go ahead and do that. Yes, I have it now. And okay, thank you, Ross. Good morning or good evening, or I'm just sorry, I should say good afternoon for some of you that are international. I am Thurman Bridgers, and I'm going to spend some time. We're going to talk about the different modes of setup using HDPQ, whether it's the portable or the semi-portable. The approach is identical as far as setting the instrument up for a monitoring application. I sort of cheated a little bit. Ross was on one instrument. I actually have logged on to another because I want to show you a monitoring setups from scratch. I didn't want to interrupt the monitoring that was going on with the instrument that Ross was demonstrating. So if the voltage values and amperage values look different, that's why we're not exactly on the same instrument. So the first approach that I want to take is, and this is the most common, and I would call it an out-of-the-box type of setup. You don't really have to get into a lot of menus and things of that nature, and that's all in the instrument design, where I can literally take the instrument out of the box, connect it to a circuit, and run this mode, which we call automatic setup, which will set up the instrument automatically for a given monitoring scenario. It's just a minimal amount of information that you have to tell the instrument or enter into the instrument to complete the monitoring setup. And so we're going to do that now by simply going to the start monitoring setup icon here. It looks like the play button on a tape recorder or similar device. And if I select it, then you see you have your different functions here: automatic setup for power quality, automatic setup for energy demand. Again, that sort of demonstrates the versatility of this particular product, where I can use it for virtually any power monitoring application. So it's not just power quality, it's not just energy demand, it can be both. So it's the most versatile instrument on the market as far as monitoring power. I like to use power as opposed to power quality. When you say power quality, it kind of puts it into this niche of power quality only. You may have an application in which you need to do a demand survey or things of that nature, and this instrument is equally capable of doing that. But having said that, our application here is going to be set up for power quality. And really, it's just a couple steps. You would select this option. What the instrument does now is it's assuming that you've already made your voltage and current connections to a given circuit. The instrument is then going to sense the number of channels that you're using as far as voltage. It's going to sense what those values are, and then it's going to come back and it's going to say, this is what my best guess is as far as the circuit type that we're connected to. And you can see in this scenario here, we're connected to a Y circuit with a nominal voltage of 120 volts. The The comes back with the nominal current, but that's the bit of information that you have to add. And then it does other things such as the frequency and how much free space you have remaining. So the first place that you have an option to, let's say, edit is the name. Very often a monitoring session, you might want to give it a unique name so you can better organize it later on in post. In this case here, you put in a unique name. The default is HDPQ. Of course, you put in unique name. The second place in which you would enter information as far as to complete your monitoring setup is the current probes. So you would have to tell the instrument wants to know what current probes are you using. So by clicking on the probe or touching, if you're local, you're presented with the current probe selection. Now, there's a couple things to keep in mind here. Number one, the instrument does allow you to mix and match. You know, there's some instrumentation out there that you have to have the same current probe on all the channels. This instrument will allow you to mix and match probes, which makes it extremely versatile for a lot of different monitoring applications. But in this scenario here, we're going to go ahead and go to the drop down. And in the drop down, you have the various different probes that are supported by the instrument. As you can see, the list is quite extensive, even our AC/DC probes. Ross mentioned earlier the instrument's ability to monitor DC voltage and DC current. Well, we monitor DC current using our AC/DC probes. So I'm going to go ahead and select the most popular probe that we sell is our Dranetz probe. And so it's a couple things that you see here. Number one, the range, our flexible probes are multi-range probes. The benefit there is that I can have one set of probes which I can use for low current, medium current, and high current applications. This particular probe has 3 different ranges that you would select from. So this is what you have to tell the instrument. On the probe itself, on the integrator, it has a range selector switch. So you want to make sure that whatever range that you have selected on the integrator, you want to make sure that it matches. This matches the selection on your on the integrator. So in this case here, I'm going to go ahead and select 300 amps. And then here, as a shortcut, I mean, you could do it the long way and do the same function for each of the remaining channels, or you can just simply use the shortcut here and it sets them all the same. So that's a way to quickly get through a setup. The turns ratio, that comes into play where for medium and high voltage applications where the instrument is basically piggybacked on existing PTs and CTs. You know, a very common medium voltage application is 4160 for 4.1 kV. Obviously, you can't bring those voltages directly to the instrument as it's rated up to 1,000 volts. So typically in those applications, the instrument is connected to existing PTs for the voltage and CTs for the current. So that's what we mean by piggybacking off existing PT and CT secondaries. Rule of thumb is that if you're direct connect, you know, up to 1,000 volts, then these values basically remain at 1. But in cases where you're going to be piggyback off existing PTs and CTs, you need to know what the ratio of those devices are. A typical ratio that you would see in 4160 is 4160 to 120, or it might be 4160 to 60. So that's a very common ratio. A common ratio that you might see for current, 3,000 to 5, 2,000 to 5, 1,000 to 5. Those are very common ratios that you would see as far as CTs are concerned. But once you've entered in the correct information, then you would go to exit. In some cases, the exit button also serves as an enter button. So in this case here, it's serving as an enter button. Once I click exit, then the settings are saved. The instrument comes back, does another detection of the circuit, and it comes back and gives me the values that I'm looking for. Now, this screen here allows you to do some sanity checks, and those sanity checks are making sure the amperage is what I expect it to be. In some cases, you might be making a connection before the circuit is energized, so that's an exception. But most of the time, you're going to be connected in which there is some semblance of current. So obviously, when we say sanity checks, you want to make sure it's reading the correct voltage values, make sure it's reading roughly the correct current values. The other thing you have from a graphical perspective, you have your built-in scope. Ross showed you an example of lifetime scope where you get this oscilloscope type display. The one thing that you can look for here, and one of the most common things that we see with particularly relating to the CTs or current probes, is what we call reverse polarity. Reverse polarity will show up very easily on this scope mode, where you can see here's your, this trace here is my current for A, here's my current for B, current for C. If I was inverted, polarity inverted on the CT, then my current would actually be 180 degrees out. So that's how you can use this screen to determine if you have reverse CTs. And of course, there's another way as well. You can use the phaser display. So if I click on phaser, I can see it from a phaser perspective. Again, if we're looking at phase A here, which is our voltage vector and our current vector, represented by voltage A and IA. If I had a reverse CT or reverse current probe, then this will be 180 degrees out. So there's a very easy way of determining if you're connected properly. So I like to use scope mode. I like to use phaser as far as the sanity checks before I walk away from the instrument. Once my meter screen and either my scope mode or my phasers are all in agreement and I feel comfortable that I'm getting the right readings, then I would hit accept. And after going to accept, the instrument will initiate the monitoring session. And so the monitoring session tells you that it's starting. The file name that you may have changed in the setup for the first piece of information that it was looking for, and then you're off and monitoring. And then, obviously you're going to leave the instrument there for X period of time. It might be a day, might be a month, might be 6 months. The instrument having 4 gigabytes of memory, you can actually have months worth of storage. For a power analyzer, data logger, harmonic analyzer, energy demand recorder, it has more memory than any instrument in its class on the market. So 4 gigabytes is a lot of memory. Now, after the instrument has been monitoring for a while, you're ready to stop a monitoring session. And so you walk up to the instrument. You can see that the stop monitoring icon, again, looks like a stop button on a tape recorder or a similar device. A couple rules of thumb while monitoring is on. All real-time functions are available. So if I wanted to go in and see something like a meter reading, and I go to something like text display, these values are all available, or I should say these functions are all available while monitoring is on. So that's a rule of thumb. Monitoring is on, all real-time functions are available. And we'll just go ahead and exit out here. However, viewing of data, you can only view data, and one of the benefits of having a local display, if you kind of want to get a quick snapshot of what you recorded before you go through the post-analysis process, is using the view data function. However, the view data function is only valid when monitoring is off. Okay, so now we've approached our instrument. We're ready to stop our monitoring session. We simply go to stop monitoring, and then we acknowledge it by stop monitoring now. The instrument goes through the stop monitoring process, and now monitoring has stopped. Okay, we're going to save the view data analysis after we complete our second option of setting up the instrument. So we'll leave that for last. So now we're, in which case, there are many times in which the automatic setup may not be detailed enough. And what I mean by that is may not give you enough flexibility. There may be changes that you need to make in the setup for a given application. There's a lot of different power monitoring applications out there. It might be inrush, might be a harmonic study, might be just energy and demand, in which the automatic setup might be too generic. So you need to customize it. Well, that's where the second mode of setup comes into play, in which we call the wizard setup that Ross mentioned earlier. And so to begin the wizard setup, you basically, the approach is still the same. It will be start setup monitoring. You just go to the icon here, and then you're presented with this window. And then the option that you're going to choose is wizard setup. And so going to the wizard setup will allow our screen to load here. And the wizard setup is going to take you through these steps. And going through these steps allows you to customize a given monitoring scenario. First thing, obviously, is the probes, and the screen or the window is going to be identical as if we were using an automatic setup, and the approach would be the same. You would select your particular current probe for the application. If it's a multi-range current probe, then you're going to select the range that you're using. If you're medium and high voltage applications where you piggyback off existing PTs and CTs, you're going to put in the appropriate ratios. Once you completed that, then you're ready to move on to the next phase, wiring config. You can move to the next phase by simply clicking on the tab here, or you can just simply hit next, whatever your preference is. If you go to wiring config, the instrument basically gives you some warning messages, obviously making sure that you're qualified and that you have all the safety requirements in place. Because remember, a lot of times I would probably say 95% of the time or more, you're going to be making connections to a live circuit. So obviously you want to make sure that you have all the safety precautions in place when you do that, all the PPE and things of that nature. So once you acknowledge the message there, then it presents you with your wiring config. Now, there's a number of, there's several pieces of information here that you get from this screen here that is very useful, very beneficial in the monitoring setup. Number one, the instrument will automatically try to go out and sense the circuit type, and it'll come back and say, I think this is a Y circuit, but it might be something different. Three-phase delta, it might be three-phase delta. This allows you to kind of override that. It might be generic. Generic is where I can use, as Ken mentioned at the onset, it's your typical 8-channel power monitor analyzer. Well, those 8 channels can be combined as 4 separate channels for voltage and current monitoring for single phase. So there's applications in which you may where that would be desirable. But in this case here, you can override it by selecting the appropriate circuit type for the given application. The other thing that you have is a reference point. So if I'm connected to a delta circuit, if my application is a Y circuit, how do I connect to that circuit? You know, rather than leafing through a user's guide, the diagram is right here, is easy to follow. You also have your phaser display, which tells you how you're actually connected and what the typical connection should be based on the circuit type. That's another, what I call a sanity check issue that you can use. Also, you can go to the scope mode if people are prefer to have real-time waveforms. You can use real-time waveforms via scope mode. The instrument as here will also check as far as making sure that you're within what we say the voltage and current measurement range that will provide the best accuracy. So what I mean by that is, for example, we see it all the time where someone will use a current probe that might be rated for 3,000 amps. but they're monitoring an ampere of current. Well, obviously you're under ranging as far as that current probe is concerned. Now, the probe amplitude-wise may read 1 amp, but your phase accuracy is going to be way off, and that's going to affect other parameters like your wattage and things of that nature. So what the instrument does here, it automatically checks to make sure that you're within the measurement range. And usually your target is to be somewhere in the middle of the measurement range to have the best accuracy. The instrument does this automatically. Now, there are cases in which you're connected to a circuit before it's energized. So when that happens, obviously your currents are not going to be in that ideal range to give you the best accuracy. So the instrument is going to come back and it's going to tell you that you have a mismatch. These two work hand in hand. If I'm under current as far as whatever current probe that I'm using, and I have a mismatch, then I'm not going to be able to determine the sequence. So those two are hand in hand. We get those calls quite commonly, and usually it's a matter of just under the current probe being under range. If you know that once the load is energized, the currents are going to fall into what we call a sweet spot. As you can see it vacillating here, then you can proceed on. And you do that by hitting next, or you go to nominal frequency tab, again, whatever your preference is. So then it loads the next page, and a lot of this is fairly straightforward, and most of the time for typical type monitoring, you're going to use whatever the default is here, but they are, and we'll talk about those in later sessions. There are certain applications in which you would need to go in and edit these windows here, but in this case here, we're just going to proceed on. The sync channel, like I said, a lot of the times is channel wave volts. There may be instances related to the type of the monitoring application in which you would need to change the sync channel to either channel D volts or even channel A amps. So the instrument has the ability to synchronize from a current signal as well. Then we're going to go to monitoring mode. And the monitoring mode, these are basically monitoring templates, and they're there to take a lot of the work out of setting up an instrument. If you didn't have these monitoring templates, and you can see each one of these are related to a given type of monitoring scenario. If you didn't have these monitoring templates, then you would pretty much have to set up the instrument from scratch every time you go out and perform a monitoring session. So these monitoring templates are merely shortcuts. They take a lot of the work out of setting up the instrument for a given application. You do have the ability, however, to go in and edit each of these templates to even fine-tune a particular application. So the flexibility is there as well. Again, the other sections here are unique to certain types of monitoring scenarios or applications that we'll cover later on. Ross mentioned that at the onset. So typically the user will select a monitoring template and then you're off to the next step. The editing of the monitoring templates that we saw in the previous screen, that all takes place in this screen here. And again, we won't get into the detailed stuff at this point, but that's how one would go in and edit any one of the monitoring templates that they've selected in the previous screen. So after you've gone in and you've edited such, then you're ready for the finalization stage. The finalization stage, there's a couple things that you have available here. Number one is viewing a configuration and then saving the configuration. This is very beneficial because if there is a unique monitoring application that you perform quite frequently, you can actually save that monitoring template and then just simply upload it every time you have that particular monitoring scenario. That saves you a lot of work. Avoid, customizing a setup every time you encounter that particular monitoring scenario. So I can save the configuration by giving it a unique name. If I go to save here, you basically give it a unique name just by typing in the information. Also, you can give the monitoring session a unique name other than the default, which is HDPQ1. After you've completed the information there, you're simply ready to initiate monitoring, again, by going to Start Monitoring or Next. In this case here, I'll go ahead and I'll select Start Monitoring. Now, when you're ready to begin a monitoring session, you do have a couple of options. Number one, if you simply just want to use it as a meter, and it'll probably be a very expensive meter and probably not the reason why you would purchase the instrument as a meter, but you can use it as a meter, or you can use it as what you probably purchased it for, and that's to basically log and detect power quality events and things of that nature. So I would simply go to Accept. And now it begins the monitoring scenario here. You can see, gives you all the information that's starting, loads the configuration, and now monitoring is on. You can tell by looking at, in my opinion, what I usually do, I look at two things to determine if monitoring is on. Number one, monitoring status is either on or off. Number two, the icon is changed from your typical play button to the stop button. So those are things that I look for to determine that monitoring is on. And as I said before, real-time functions are available while monitoring is on. View data is not. So monitoring would have to be turned off. So you've been monitoring for a while and now you're ready to view data. Get a quick preview. Chances are you're not going to do a detailed analysis of data using the instrument's local display. That's what the software is, which is included. DranView, that's what the software does. But a lot of times, since you have a local display, you may want to see a quick preview of data. So this is how you would basically do that. When monitoring is off, again, following the rule that monitoring must be off, and we go to Stop Monitoring. Now the view data function now becomes available. And so by going to view data, I can basically go to an event list. I can see if there was any events recorded. You can see here, this is a quick snapshot of data from the monitoring sessions that we've done earlier. Or I can view any trend data. Now, we probably haven't been monitoring long enough to give us any real useful trend data, but you would basically have your trends, just like if you're viewing a time plot. You have the ability to view event lists, any waveform data, if you want to go that far as to doing waveform analysis. So again, and really what I use the local display for in monitoring applications is to kind of give me a snapshot of what I have before I go to the next, before I go to post as far as analyzing the data. So these are some of the tools that you have there. Now, a very common scenario that comes up is that I've been monitoring for a while. Now I'm ready for the next step. I've gone in, I've done my preview. I know I have data there in the instrument. I know I have a data file. So now the next step is, well, how do I get that data to the software, which is the DranView software for post-analysis, reporting, things of that nature. So there's basically two ways of getting data from the instrument. One, and you heard the term early on, sneakernet. That's basically walking up to the instrument with a thumb drive, inserting it into the USB port, and then going to the appropriate screen, which I'm going to show you shortly, as far as saving the data to a thumb drive. And then basically sneaker that over to your computer, running the software, plug it in the computer USB port, launch the software, read the data file. Okay, that's one way. The other method is establishing a communication link to the instrument and downloading the data via communication. Again, that lends into the instrument's versatility, because there may be occasions where the instrument might be in a remote location somewhere, and maybe you have a connection to it via wireless modem or something similar to that. And the instrument itself can support wireless modems. Is virtually plug and play via the instrument's Ethernet port. So you can make a connection to the instrument to download data. You can make a connection to the instrument for remote setup changes, things of that nature. But so let's look at the first scenario, which is archiving the data to a thumb drive. Once a thumb drive, the first thing you want to make sure is that when you insert the thumb drive into the USB port on the instrument, and Ross mentioned this earlier, you want to make sure that the instrument has acknowledged that it sees the thumb drive. And so it does that by giving you the thumb drive symbol in the icon that looks like a computer screen. So once we have that acknowledgement, it's recognized the thumb drive, then we're ready to go to the next step, which is navigating to the appropriate screen that will allow us to download the data. The other thing, the other point to remember, and you do this by going to manage memory. When monitoring is on, you do not have access to manage memory. It'll lock you out. So again, monitoring has to be off. How do I know monitoring is off in this scenario? Well, let's see this icon here. It's the play button. So if it was the stop button, that means monitoring would be still on. But since it's a play button, I know that monitoring is off. And now that gives me access to the manage memory function screen. And what you see here, and this is some things to note here, a monitoring session, each one, you can see each one is monitoring sessions here. You can actually see some new ones that I basically created during our session here. So a monitoring session is anytime you initiate monitoring and the instrument stops for whatever reason. And it may stop because you manually stopped it, or it may stop because maybe the instrument ran out of battery and then restarted. Or so anytime it starts and stops, it creates a monitoring session, which is why you see all the sessions here. So it's very important, and we see this a lot, is that if you're looking for data within a certain range, you want to verify that you've downloaded that particular monitoring session. If you have a monitoring scenario where maybe you created multiple sessions, maybe someone inadvertently turned the instrument off, turned it back on, you want to make sure that the data that you're looking for is within the range. You have your start and you have your end, and you have the number of records in a given session. So you basically select each one that you want to archive, and you use to archive the USB, and it'll begin the process of archiving the data. If you have a scenario in which you have multiple monitoring sessions for a given monitoring period, you can download them individually, and you can stitch them together in DranView. That's one of the PC software. DranView has a function that will allow you to stitch them together. So don't panic if you have a monitoring scenario and it has more than one session in it. You can certainly do that. So after you've archived the data to USB, now, as I said earlier, you go over to the computer and running DranView. You simply use we're going to exit out of here. You simply use the file open function, navigate over to where the thumb drive is, and then read in the data files. So now the next scenario I'm going to take you through in my final home stretch here is, how do I get data via remote connection? Well, number one, in DranView, on the ribbon bar, on the taskbar, you have your download function. So you would select the download function. When you're setting up a new download session, you give it a name, the IP address, the user, and password. By default, the username is admin and the password is Dranetz with a capital D. So that's the login credentials. Once you have created the login credentials and you would make a connection to the instrument, this probably looks very similar to if you were viewing the instrument locally. You have all your monitoring sessions here. And so you would just basically check off to which monitoring sessions that you want to download. Okay. And again, the key here is making sure that the data that you're looking for falls within these windows here. Sometimes users will have an instrument that will have monitoring sessions that are very old. They forgot to clear the memory or whatever. And so it's very important to keep in mind that the data set that I'm looking for, I want to make sure it falls within the range of a particular monitoring session. And also keep in mind that you may have multiple monitoring sessions for a given monitoring scenario for the reasons that I explained earlier. And the other option, I'll finally end on this. If you want it to be more selective, say if I selected a monitoring session and I only want to download a certain part of it, you can use these drop downs here, or you can be more selective. If only you're looking for an hour's worth or a day's worth, so you can use those options. Okay. The next step would be to visualize and analyze the data, and I'm going to pass that over to my colleague, Ken DeMario. He is going to take you through a tour of typical viewing and analyzing of the data. So I'm going to stop sharing, Ken, and it should be all yours at this point. Thank you, everyone.
Thank you, Thurman. Let me get some data up here. I looked at the same data, same HDPQs that Thurman was just looking at. I downloaded data for the last 2 days from our service engines right here. When you get a hold of data from the HDPQ, as Thurman said, you download it. I looked at data from the last 2 days. I just highlighted what I wanted. And let me show you exactly what you have to do. I just called the Edison service entrance, Y, admin, and the password is Dranetz, and just told it to download for 2 days worth of data. And it took 2 minutes, 3 minutes. When you look at the data, first thing comes up is it shows you the 4, since this is a Y, the 4 voltages. If you want to look at voltage and current together, just find a empty spot on the graph, right click, go to properties, and bring up the chart properties. What I want to look at is the 3 voltages and the 3 currents at the same time. Just highlight what you want, and you will get your voltage and your current. If you notice over here on the left-hand side, these are events that happened in the last 2 days. And if you notice the little triangle up at the top, as you change to different events, it's going to show you where you are and show you what happens over here on the right-hand side. So on the center plot, we have our time plot with our data. The right is the event detail. And we had a little bit of a dropout for, 1/16 of a cycle right here. So that's what will happen back and forth between the two of them. If you want to see the high and low, you can also insert a table and do statistics, and it'll show you the min, max, and average of the data right then and there. There are multiple ways. We're going to do a full DRAM view analysis, but I just wanted to show you the last 2 days of data, give you a quick overview of Dranetz data, and that's basically it. So I'm going to turn it back to Ross right now, and you can look at that later on.
All right, thank you, Ken and Thurman. Good
Okay.
job. We appreciate it.
Yeah.
So that's a general overview of how DranView works, how the instrument works, how the setups work. Again, for the specifics of those, please focus on the application sessions that we're going to have, and we did have last week, and we're going to continue next week. So we'll give specifics on instrument setup for those particular applications, and also on the analysis end, as we did with the generator testing from last week. So we're going to open up to questions, and if I could just ask the other guys to mute their audio here, please. All right, thank you. We have a couple questions that came in, and I'll ask Ken and Thurm to help with these things. First one from Patrick, since you're not using a current probe on the neutral, do you turn off D in the probe tab? Right, yeah, we would suggest that you do that. There's going to be no harm in leaving it on, since you won't be triggering on it, but you can certainly turn that off. It's mostly your option, but it would be the best way to do things. Melissa asks, can we remotely restart or stop monitoring? Of course.
Yes.
That's basically what Thurman showed. You have the ability to do that. Ken, will you please? So you have the ability to fully remote control the instrument. Everything that you can do on the front panel, except for physically turn it off and on, you have the ability to fully remote control the monitoring, the setups, and starting and stopping monitoring. And that's either through DranView in the VNC or in a separate VNC, remote VNC application. And again, that app can be downloaded from the Apple Store or the Google Play Store on your smartphone or on your tablet as well. So it does not have to be PC-based. DranView is PC-based, but the three VNC apps, and you want to make sure it's a VNC viewer, can be downloaded at no charge from your preferred app store. Okay. And I think that's it for the questions that we have right now. We have another one from Melissa.
Yeah, it's in memory capacity.
Okay, why don't you take that, Thurm?
Sure, I can take it. Yeah, 4 months is certainly doable by default, but there is some things to keep in mind. There's a couple factors. Number one, the sensitivity of thresholds. You know, the instrument is report by exception. You can basically tell it what's good or what's bad. So that, in a sense, is its sensitivity. And then also the activity on a given circuit. But typically speaking, with 4 gigabytes of data, 4 months of monitoring would be plenty. Especially if you're using it in a data logging mode, it's plenty.
Yeah, absolutely. It's you know, quite candidly, if you've got 4 gigabytes of PQ data over several months, you probably have a very severe PQ problem, or the instrument isn't connected or isn't configured properly. So it's more than enough memory. So we have another question from Michael. In events, what does waveform mean? And I'm assuming, Michael, you're referring to when Ken was showing you the DranView stuff. Waveform would be, would that be a waveform trigger, guys?
Yes, it would be waveform trigger. Yeah.
We spoke about this in the generator testing last week. It's something very unique to Dranetz, and that's that cycle by cycle comparison for changes in cycles. And that was key to the generator step load testing that we discussed last week, where what it's doing, there's 2 different ways to do it. And the most common way, it divides a waveform up into these little windows as a % of the 60 hertz cycle. And you compare that same window to that same window in time of the previous cycle. And if it changes by the amount that you've programmed, that's a wave shape event. And Michael, that's what you're seeing as a wave shape event. And that's what triggered that short change that Ken showed us earlier. Jay asked, can you go over how to set up remote monitoring? Yeah, we could do that real quick.
Yeah, I can. Yeah, let me take that.
Let Thurman do it. And I'm assuming, Jay, you're talking about the communications part of it.
Yep.
And so I'll ask Thurman to go through just the IP setup and DHCP versus static and stuff like that. So
let's go back to our previous screen here, and we'll share it from this aspect here. I'm going to establish, and here's an example of the end result of remote monitoring that was mentioned earlier, as far as, you know, turning off monitoring, turning on monitoring. Here I actually established and to Ross's point, VNC, the VNC viewer is the component that is used to communicate with the, in this case, HDPQ. The HDPQ instrument itself has a built-in Vnc server that's actually built into the instrument. And so to interface with the Vnc server, you will use a Vnc client. There's 2 options. One, as to Ross's point earlier, you can go to your favorite web store and download the Vnc client, and so you have that end of it to communicate with our Vnc server. Or more conveniently, since DranView is included with all the HDPQ packages we sell, you can use the VNC client within DranView, which is what we're doing here. I do this for mainly for convenience. So if I'm setting up a remote session to an instrument, I would simply go to New, and then I will give the session a name. You can see here it uses a default name, and then I would enter the IP address, and I'll show you later an IP address setup. So I would enter the IP address that's been assigned to the instrument. Now the instrument can basically acquire IP addresses in 1 or 2 methods: static, which we recommend, or dynamic, which is DHCP. So if the instrument is on a local area network and you can have it get its IP address from a DHCP server, our recommendation usually in remote setups is to have a static IP address assigned to the instrument. So in this case, you would enter the appropriate IP address, and once you've done that, then you're ready to communicate to connect to it. In this case here, if I select the session I created previously, I go to connect. Now I have remote communications to the instrument. Now one says, well, how do I set the instrument up for that? And so the other option is you go to set up communication options. So by going to this function here, and again, I'm doing this remotely, but if you're local to the instrument, you would just simply, do it locally on the instrument. So here in this setup here, you can see I'm using a static IP. I'm not using DHCP. Again, where I would use DHCP, I should say, is you want the instrument to acquire an IP address from a DHCP server that might be on a local area network or a wide area network. In this case here, I have a static IP address, which I've signed to the instrument. It comes with the subnet mask and the gateway. That's all I need as far as setting up an IP address for the instrument. Then the other thing here under, as I mentioned earlier, the instrument has a built-in Vnc server. Well, the Vnc server, as you saw in some examples, the username and password, here I would define first of all, to enable the Vnc server. So in those applications, which maybe because of security reasons, things of that nature, you want to disable the Vnc server to keep someone from logging on, you can do that. If Vnc server is enabled, then you can give it a unique password. The factory default, of course, is Dranetz. So once you have that set up, now you're ready to communicate to the instrument for remote programming, to turn monitoring on and off remotely, and of course, to download data. So I hope that answers your question.
Okay, very good, Thurman. Just if I could add that one of the reasons not to use DHCP in IT terms, it's a leased IP address. And even though you can easily know what the IP address is or was that was assigned by the network, in theory, it can change. So if you turn off that instrument and start it back up again, you may have a different IP address. Just a second thing to add on some of the things that Thurman said, when you're remotely configuring the instrument, be very careful with the IP address because you are by nature already configured for IP communications. You've established that connection. But if then you go ahead and change that IP address, now you've locked yourself out of that instrument. You would need to reconnect, and it has to be a proper IP address that you enter. So, just little words to the wise there, just to add to what Thurman said. Kyle asks if you set the monitor's character mode to all data versus triggering, how long can we monitor versus with the 4 gigabytes? And I'm assuming what you're saying is just using journal and trends versus the triggers with the PQ triggers with wave shapes. And that's kind of a difficult question to answer, Kyle. It's you can probably go for a year or more. A lot of it depends upon how frequently you set those journals, those timed intervals. At the factory defaults of 10 or 15 minutes, whatever the particular parameter is, it'll record for a year or more. We do not specify that because there's so many variables involved, but that's just a general rule.
I think if I could just chime in, I think what Kyle might be asking, does the characterizer mode dictate how much data gets stored in the instrument? The characterizer mode in the instrument simply, if I can put it in layman's terms, how do I present the data? For example, if I have a reduction in voltage, how do I characterize that? Is it a sag? If it's an increase in voltage, how do I characterize that? It's a swell. If I have what we call a spike, or you might call a transient event, how do I characterize that? Do I characterize it as a multi-cycle transient, things of that nature? So there's one thing is what determines how much data gets stored by the instrument is the instrument setup. Again, how tolerant or how sensitive you make the instrument to recording data. To Ross's point, your journal intervals and things of that nature. That determines how much data the instrument will collect. The characterizer mode basically tells you how to characterize the data, what it means, putting it in simple to understand terms. So I hope that answers your question.
No, that's good, Thurman. Thank you. Tony asks, will you go over viewing RMS instantaneous or harmonic data? Not at this session, Tony. We're going to actually focus on that in 2 weeks when we get back to our application training. We're actually focused on IEEE 519 2014 harmonics, and we can certainly address that. But just to briefly answer your question, you have the ability in DranView, and certainly in the instrument itself, but it's easier to do in DranView, of viewing any voltage channel, any current channel, viewing the voltage of the current, or individual harmonics that may have been recorded by the instrument or the VTHD and ITHD. But we will definitely be elaborating on that in our next session when we cover the IEEE 519 harmonics, because it directly relates. Excuse me, Kevin asked, if I set up the meter for energy monitoring, can I still access PQ data in DranView? The answer is maybe, because it depends upon what you're recording. In general, energy is not PQ. If you need PQ, you need to enable the PQ capabilities. But there is overlap, such as in THD and things like that. But you're not going to get the sags or the dips or the swells or the transients and the wave shapes associated with them. But you will get a minimal amount of PQ data in there. So the recommendation would be, if you want PQ, even though your focus is energy, well, we have the ability to do that. It's a unique capability of the Dranetz products. It's kind of an a la carte setting where you can enable what's important for your application. So you can go to a monitoring mode that'll record a default set of parameters, and you can add to that for your particular application.
I would also add to that is that if you set up the instrument for just using one of the monitoring templates that I talked about earlier, the most common monitoring template that's used when someone's going through the wizard setup is the first one, which is standard power quality, I believe is IEEE. If you use that monitoring template, it's focused to power quality, but it's also going to provide you with energy monitoring as well. So just to add on to that.
Very good, Thurman. Thank you. And then Jay also asked, can you use any IP number? The answer is absolutely no.
Yep.
It has to be an IP address that's valid for the network that you're configured. As an example, if I'm going to plug into my local network here, I have to know what the valid IP address is for your network. If you're unfamiliar with that, I suggest you speak to your IT person or contact Ken or Thurman or myself in tech support to help out. Because it is, these are not Dranetz rules, these are networking rules with the IP stacks. So there's certain ranges of addresses that are valid, not only to just enter period in IP network, but that will function on your network. So, however, when you're directly connected from a computer to HDPQ, as long as they're on the same network and you've configured both to do that, it's kind of random which IP address you will choose to assign to each of those, the instrument or the PC within the range of valid addresses that you choose. So a little bit complex, but ask us for more help. And then Kevin asked, excuse me, how is remote config done different with Wi-Fi? If you're talking about remote config of the instrument, as Thurman demonstrated, it's exactly the same. Once you're up on a Wi-Fi network, the connection to a Wi-Fi network is a little bit different than just a regular Ethernet, because you have to find your hotspot that or your router that you're connected to, make that connection and enter in any security that's compatible. Once you establish that connection, it's absolutely exactly the same as you're doing with an Ethernet cable. The instrument doesn't know the difference. You don't know the difference once you're connected. Melissa asks, what are the expected reasons for monitoring to stop unwillingly? Temperature below certain degrees Fahrenheit or whatever. How long is the battery life for continuous monitoring? When there's really no normal reason to stop other than maybe memory filled, something like that it's programmed to do. But there can be exception situations where the battery or the instrument loses power, as you're alluding to here, and the battery depletes. And in those situations, it'll restore monitoring. Once it is back energized, it gets mains power back. The battery life is about 2.5 to 3 hours, depending upon the model. Let's say 2 to 3 hours, depending upon the model. Where the Explorers don't have quite. It's about 2.5 hours. The Visa and the Guide is about 2.5 to 3 hours battery. And that's because the Explorer has high-speed transients in it. It's additional circuitry, additional loading on the battery. But to answer your question, it's when something happens. The instrument may have a fault or something, it reboots itself, or usually the instrument lost power and the battery depleted. Those are the reasons to unwillingly, in your terms, stop monitoring. And then John asked, is there any problem with leaving the charger connected during monitoring? Absolutely not. We recommend that you do that. That keeps the battery charged, and I'm assuming that it's more than just a few minutes that you're recording, but certainly that's what keeps the battery charged. The battery's UPS for your monitoring application. So we would recommend that you do that. And I think that's it for the question. So, we'll be here for a little bit of time. Please chat up any additional questions. We certainly appreciate your time today. Again, our next session, we're skipping next week due to our Thanksgiving in the United States. Our next session will be on December 2nd, and we're going to cover the IEEE 519-2014 VFD and DC monitoring applications and the setup and the specifics for those. So thank you very much. Happy Thanksgiving to everyone here in the United States. Stay safe, and we hope to see you on the 2nd.